Hello, let's continue our Sudoku adventure with Shared Space by Matt Tressel. So this continues our Renban theme week. Hopefully I'll do better with the Renbans than I did yesterday. I got very confused by the fact that they were Renbans and region sums, and I completely missed an obvious deduction, so apologize for that. But hopefully it was a fun solve anyway. But anyway, for today, we've got Renbans and Kropkis. So let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these purple lines in the grid. These are Renban lines. So that's what our whole week is about. Digits on the line form a set of non-repeating consecutive digits, but in any order. So, for example, a non-repeating consecutive set of digits might be 2, 3, 4, 5. They could be in any order. We could go 2, 3, 4, 5, right? So the order we don't care about on the line. What we care about is the digits aren't repeating, and when you take them as a whole, they form a fully consecutive set, right? You just can go boom, 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 add 1 to get to the next. So 2, 3, 4, 5, right? We can't do 2, 3, 4, 6. We can't do 2, 3, 5, 6. 5, 6 are consecutive, 2, 3 are consecutive, but the whole thing together is missing the 4. So it's not consecutive. All right, in addition to that, we do have these black dots in the grid. Digits separated by a black dot have a 1 to 2 ratio, meaning one is exactly double the other. So if this was a 2, this could be 1, because 2 is double 1, or this could be 4, because 4 is double 2. Not all the dots are necessarily given. So if this was 2, 4, there could have been a black dot between them, but there's not, and that's perfectly fine. Black dots only tell us about the cells that they occupy. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I'm going to start with the long Renban here. So this is 1, 2, 3, 4, 5, 6. So this has every digit. So we know that these two digits are the same as these two, because they have to go somewhere in the box. And so they're actually separated by a black dot also. Do I want to color that? I mean, I guess I could make these green and these green. You represent the two digits. We don't know what order they go in. We have a black dot here as well. That probably means something. Oh, interesting. Okay, this means a lot. So notice how the two green digits are separated by a black dot, but we know that this is one of the green digits. So these two digits, the greens, need to go in this box somewhere. They're not going to repeat in the row. So 2 greens go up here. One of them we know is here. The other one is going to be on our black dot. But if it's on the black dot, it means it's part of a black dot ratio that isn't both greens. So what that means is we need to be able to chain basically 2 black dots together. And so the only way to do that is 1, 2, 4, at least in a 6x6. In a 9x9, you can do 2, 4, 8. But in a 6x6, 1, 2, 4 is the only way to do it. We can go from 1 to 2 and then 2 to 4, doubling each time. If we start with 2 even, we go 2 to 4 and then 4 to 8, and 8's too big. So that means that there's actually is a 2 on here and on here. And then this is a 1 or 4, which means this has to be the 2. Okay, that's pretty neat. And so then this is a 1, 2, 4 here. And this is a 1, 2, 4. Okay, so I don't think I need to keep the green around. I think this is clear now. So this whole row is 1, 2, 4 then. And then this whole row is 3, 5, 6, making this 3, 5, 6. And if this is 3, 5, 6, it's on a 4-cell Renban. This better be a 4 to bridge the gap between the 3 and the 5, 6. Making this a 1, making this a 2, 4 pair. And so now 1 can't repeat on the Renban, making this 4. Right. And the greens would have told us the same thing, but this worked out just fine without the greens. All right. Cool. And now you can see that this is a different black dot than this. It had to be. Now we have 3 consecutive digits here. They all can't be 4. So we're not doing 4, 5, 6, meaning if we can't use 4 at all, 1, 2, 3 is the only option. Can't do 2, 3, 4, 3, 4, 5, 4, 5, 6. They all have 4s in them. And so that does place the 2 down here. Placing a 4 and the 2 here. These are consecutive, but I don't think we can do much with that. Oh, we know what these 2 digits are. Well, we know the order at least. They're 5, 6. And so from a 6, we'd have to go to a 5. From a 5, we'd go to a 6 or a 4. So there is always a 5 in one of these two, meaning this can't be a 5. Okay, what's next? We have this black dot. We have this Renban, which we haven't looked much at. I think, let's see, 1, 2, 3, 4, 5. So a 5-cell Renban, one easy way to think about it is it's missing one digit, right? Because it's not 6 length, it's 5 length. It's missing one digit. The digit it's missing has to be an extreme, a 1 or a 6, because otherwise we'd be making a gap between two different digits. Like if we're missing the 2, which is relevant here, if we were missing the 2, then we would have to include the 1 and the 3 because we're only missing one digit, and the 1 and 3 wouldn't have anything to bridge that gap. So this needs all the digits except 1 or 6. One of them is missing, and the 2 can't be in any of these. So the 2 ends up here. And then, oh, this is a 5-6 pair, meaning these can't be 6. The 6 goes up here. Doesn't mean it's missing the 6. This could be the 6. Okay. This is 3, 5, 6. Does that help me on this Renban? We know that this isn't a 1, 2, 3 Renban because this 1, 2 here. If this was 1, 2, we have too many 1, 2s in the phone. We can't have 3 cells that all want to be from 1 or 2. So if this is a 3, we do still have to go up to 4. So there's definitely a 4 in one of these two. That's the conclusion. Because if this is 5 or 6, we're definitely including a 4. A 6 would be 4, 5, 6 exactly. The 5 could be 4, 5, 6 or 3, 4, 5, but either way it uses a 4. And then the 3, since it can't go completely down, the lowest we can go is 2, 3, 4. So yeah, 4 is always used. Hopefully that's clear. So with 4 missing from here, we could be 1, 2. We'd be 1, 2 like this. We cannot be 2, 2, 4, but we could be 3, 6. I don't know how helpful that was. What haven't I looked at yet? I wonder if this has more to it. I'm not sure that it does. If this was a 6, this would have to be 1, 2. That seems completely reasonable, though. If this was 3, 6, this would be 3, 6. Oh, 3 and 6 and 5 and 3. And it works. There's got to be something simple here that I'm missing. This has to have a 1 on it. That's what I'm missing. This 1, 3 tells us that 1 and 3 are both down here. 1, 3 pair, right? And so if this Renban has a 1 on it, it has to be missing the 6. So that's 5, that's 6. Gives us the 3 and the 1. Giving us the 6 and the 5. That's a 3. That's a 3. All right. Well, we know it's going to be 3. Well, either 2, 3, 4 with a 2 here and the 4 here, or 3, 4, 5. 4, 5 going either way. This can't have 3 on it, which means it is a 1, 2. Which means that is a 1. Giving us the 1, 2 here as well. So this is 3, 4, 5. 4, 5 pair. That can't be 5 now. That places the 1 here. Okay. Got a bunch of stuff. This is just 3, 4. You know the order, 3, 4. 5 or 6. Can't be 5 because the 4, 5 pair. So that's our 6, and that's our 5. All right, this is a 3. That's 6 and 3. That's our 6. This is a 5. Finishing up here. Down here, I do need a 3. Oh, no, I don't. I already have a 3. I need a 6. And then this is 4, 5. And this Renban resolves it. Can't do 6, 4. So that's 5, that's 4, that's 4, that's 5. We're done. Yeah, just missed this key step here, and I just had to waddle around until I noticed it. Yeah, I had everything deducted about this line except, oh yeah, this 1, 3 pair ended up down here, and so therefore it has a 1 on it. Okay, cool. Neat puzzle, Matt. I enjoyed that. Nice use of Renbans, a lot demonstrating a lot of the different properties that Renbans can use. I hope you enjoyed this as well. And if you did, why don't leave a like, subscribe, and a kind comment below.